Okay, so we are going to start looking at this alternative system of angle measure called Radian Measure, where instead of measuring angles in degrees, you're going to measure them in things called radians. So what is a radian? What's it equal to? What size is it? Basically, an angle of 1 radian is an angle that has its vertex at the center of a circle, and it intercepts an arc on the circle that's equal in length to the radius of the circle. So basically, if you think about taking my radius of whatever circle I've got, so say on this one from the middle to the outside, that's my radius, and like bending that and wrapping it around, the angle measure created by that is an angle measure of 1 radian. If we're talking about like 2 radians, that's the angle formed by wrapping 2 radiuses around the center or around the outside of your circle. So let me show you kind of a little picture. Okay, so this starts out, okay, here's my radius of my circle. And I'm going to wrap 1 radius around the outside, and that's going to create an angle measure of 1 radian. So wrap, wrap, wrap. That's 1 radian. If you repeat that process and take another radius and wrap it around, that's an angle that measures 2 radians. Again, is 3 radians. Actually, in terms of a circle, it's 3.14 or pi radians around half of your circle. Takes that many radiuses to get halfway, and then your full circle is 2 pi radians. Which makes sense if you think about circumference, it's 2 pi times the radius of your circle. So 2 pi radians is your degree measure for the whole circle. It's equivalent to 360 degrees. So this is part of the reason why I said always write your degree measure symbol if you want to make sure that you know we're measuring angles in degrees, because if no unit of measure is specified, then we're going to assume that our angle is being measured in radians. So if I see 30 as an angle measure, that means 30 radians. You don't have to write the word radian or anything. That means 30 radians if you just see 30. It's not the same as 30 degrees. So make sure that if you mean degrees, you label it in degrees. Let's do a little approximating. So if we take all of these circles and draw some angles that are the given radian measure, what's it going to look like? Okay, so like 1 radian, we already talked about, is like wrapping 1 radius around the outside of your circle. So these are kind of going to be approximate here, but it looks like if I made that my central angle, that would be an angle of 1 radian. If I'm talking 2 radians, this is a smaller radius because it's a smaller circle, but 1, 2 approximately, that looks like an angle measure of 2 radians. -3 radians, just like in degrees, that'll mean we're going clockwise, so I need to wrap 3 radiuses around this circle this direction. Do a little arrow to indicate that I rotated in a clockwise direction. And then 1 radian on this little circle should match up and be proportional to 1 radian on my big circle. So it doesn't matter what size of circle that you're using, 1 radian is still gonna be the same angle measure on a little circle as it is on a big circle. So keep that in mind. Okay, one thing we're going to have to get really comfortable with is converting back and forth between radians and degrees, especially on our major common angles, like our 30, 60, 45 degree angles. So the easiest place to start is to think about the fact, I think, that the whole 360 degree rotation is 2 pi radians, and break it down from there. So 360 degrees equals 2 pi radians. If we go over to 180, that's half of 360, so that's going to be pi radians. If I go in the middle of those two, 1.5, or 3 pi over 2 radians, has to equal 270 degrees. And then thinking about And between 0 and pi, half of that for my 90-degree angle would be pi over 2. Then we can kind of base the rest of our angle measures on thinking from those. So let's think about like our multiples of 45 degrees. So if 180 degrees is pi, 45 degrees is 1/4 of that. Because if I cut my pi radians into little sections here, I can cut it in half to get pi over 2 or 90, cut that in half to get 45 degrees. So 45 degrees is 1/4 pi, or pi over 4 radians. And then I can just go and add multiples of pi over 4 for every 45-degree angle measure that's added. So like this is 1 pi over 4. 90 degrees is another 45, so it's 2 pi over 4, which I know I already have it labeled as pi over 2, but this makes things easier to think about. If I go another 45 degrees to 135 degrees, that's another pi over 4 radians, so that's 3 pi over 4. Down to 180 is 4 pi over 4. Another 45 puts me at 225, which is 5 pi over 4. Another one makes us 6 pi over 4. And keep going. 7 pi over 4 is 215. And then 8 pi over 4 is 2 pi. So I'm going to erase the ones that I don't really need because I already have simplified versions of them. Okay, so that gives us all of our angles that are multiples of pi over 4 between 0 and 360 degrees. Let's use kind of that same thinking to get all of our multiples of 30 degrees. So again, kind of thinking about breaking this down from pi. If I think about 30 degrees is 1/6 of 180. So if 180 degrees is pi, 30 degrees is going to be pi over 6. And then for every 30 degrees that's added, we get an additional pi over 6 added to our radian measure. So 60 degrees is going to be 2 pi over 6, another 33 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7, and so on and so forth, just counting by pi over 6s. And I will reduce these in my final picture. I'm just sort of counting them up right now. So whenever I'm labeling all of these angle measures, this is exactly what I think through to get my angles in radians labeled. So let's reduce some things. First off, let me erase the ones that I already had labeled in their reduced form. Already got it. And all these little red arrows because they're going to bug me. Okay, now let's reduce some fractions. 2 pi over 6 is just 1 pi over 3. 4 pi over 6 is 2/3 pi. 8 pi over 6 is 4/3 pi. 10 pi over 6 is going to be 5/3 pi. And yeah, there it is all labeled. So using that kind of same idea, the fact that pi radians equals 180 degrees, we can convert any angle measure, even one that's not a nice like fractional multiple of pi, from degrees to radians or vice versa. So if you're converting from degrees to radians, you can just multiply by pi over 180 degrees. So if I think about converting 90 degrees to radians, I could do and get the same thing as I just got, pi over 180 times 90, and then reduce 90 over 180 would be 1 over 2, or pi over 2. When we're doing these, we want to give exact values when possible, so not rounded off decimals unless we absolutely have to. Try to leave them in terms of pi. If it's already a decimal, however, it is okay to write your final answer as a decimal. So if I'm changing this one, 3.13 radians, 2 degrees, I could multiply by 180 over pi. To keep your direction to multiply by, right in your head, you can think about the fact that you want your units to divide out. So you want radians on top and then radians on bottom to get this to divide out to an angle measure in degrees. So if I do this one, I don't really want whatever 3.13 times 180 is over pi. That's just a messy decimal anyway. So I'm just going to type the whole thing into my calculator and get 179.335 degrees approximately, which makes sense because 3.13 is really close to pi radians, and pi radians equals 180 degrees. All right, let's go from degrees to radians. If we're going to do this one, 3.256525 degrees times pi over 180 degrees. Your calculator may or may not give 325 point blah 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 over 180 to you as a fraction. If it does, that's fine. You can also just go ahead and multiply the pi in as well and get 5.684 radians approximately. We haven't thrown any trig function values in there yet, but if you want to find trig function values of angles that are in radians, the easiest way to do it at the moment is to just convert your angle measure from radians to degrees. So if I'm doing pi over 6, thinking back to your breakdown, your picture, 180 degrees was pi, so 1/6 of that would make pi over 6 30 degrees. So we could use our special triangle, our 30, 60, 90, to think about what cosine of pi over 6 would be. So 1, 2, square root 3. Cosine of pi over 6 is the same thing as cosine of a 30-degree angle, which is just adjacent over hypotenuse, so square root 3 over 2. Same idea with cotangent of pi over 4. Again, pi is 180 degrees, so if we go 1/4 of that, we're at 45 degrees. And then thinking about our special triangles, if we want cotangent, that would be adjacent over opposite, which is just going to be 1 over 1. So cotangent of pi over 4 is just 1. Secant of 5 pi over 3 is a little bit harder to think about since it's down in quadrant 4. You could flip back and look at our picture, or you could multiply by 180 degrees over pi and convert it that way, and that would become 60. Our pi's will divide out. So that's the same thing as secant of 300 degrees, which means, ooh, ugly picture, I've got a 60-degree reference angle. And if I'm thinking about secant, make sure you think about your positives and negatives here. I'll have adjacent over hypotenuse would be cosine. So this is going to be hypotenuse over adjacent is just going to be 2 over 1, and it's positive.